How does the US and the EU stand up to China's hydrogen platform? And Dominion Energy announces hydrogen blending in Utah. I'll go over all of this on today's Hydrogen Podcast. So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. In an article in The Hill, Ismail Rueda, Henry Van Soest, and Andrew Starr write, "Will China's green energy push threaten the West's hydrogen plans?" The authors write, "Hydrogen plays a key role in the decarbonization plans of the European Union and the US. Both have launched aggressive hydrogen strategies to increase the generation of hydrogen and the deployment of related technologies. But these bold ambitions may face headwinds caused by the acceleration of China's energy transition. China is adding new renewable projects to the grid as fast as the rest of the world combined. And Chinese leadership in solar and wind technology and manufacturing is well documented. China leads the world in hydrogen production and consumption. China is also a serious contender to take the lead in hydrogen research and development. For instance, China's 14th five-year plan has identified hydrogen as one of the frontier areas that the country pledges to advance. If the West is to realize its hydrogen plans, proactive policies may need to be put in place to maintain competitiveness with China on hydrogen research and development, increase access to hydrogen critical materials like iridium and nickel, and support the development and completion of hydrogen projects. If the EU and the United States want to achieve the ambitions set out by their respective hydrogen plans, it is critical to counter Chinese dominance over the supply chain of critical hydrogen components such as electrolyzers and fuel cells. The EU and the US are investing heavily in hydrogen. The EU is proposing a hydrogen accelerator on top of its hydrogen strategy, where it will produce 10 million tons of hydrogen and import another 10 million tons of renewable hydrogen by 2030. This effort is seen as an important component in reducing its dependency on Russian hydrocarbons and achieving energy security. In line with its decarbonization goals, the US has launched a $7 billion initiative to jumpstart a clean hydrogen initiative and is developing a national clean hydrogen strategy and roadmap which contemplates increasing production of hydrogen to 10 million tons by 2030. The U.S. has also included provisions to subsidize clean hydrogen production in the Inflation Reduction Act, with a production tax credit of up to $3 per kilogram of hydrogen produced for hydrogen plants within the first 10 years of operation. Japan has also committed to hydrogen and plans to increase its hydrogen capacity to 20 million tons by 2050. China is the leading manufacturer of several critical clean energy products such as solar panels and wind turbines. China may be close to leading production of hydrogen technologies as well, specifically hydrogen produced using renewable energy. China's developing lead in hydrogen can be seen in different ways. First, Chinese alkaline-based electrolyzers used to make hydrogen from water cost a third of their US and European competitors. Second, China plays a role in the supply chain of minerals required for electrolyzers. For example, China refines 68% of nickel globally. Third, China leads hydrogen research and development in quality of research and flow of human talent, which means that new technologies that could cut the cost of green hydrogen may come from China. Finally, China's large and growing renewable energy capacity may make it the leading producer of green hydrogen. Right now, the EU and the US strategies focus on increasing production of hydrogen, but they may not sufficiently account for the sourcing of critical machinery and the critical materials they rely on. European and American companies could be at risk of being crowded out by access to critical materials, and they may find themselves becoming importers of hydrogen clean technologies. To meet their hydrogen plans, the EU and US may find themselves in one way or another depending on China. The US and the EU should implement policies that increase competitiveness of locally produced critical components. Proposed policies to increase hydrogen production should go together with policies supporting factory automation and domestic production targets. This way, Western countries may be able to generate enough cost efficiencies and economies of scale to compensate for China's lower labor costs while offering higher quality products. The EU and the US see hydrogen as a crucial pillar of their energy transition, but it's much cheaper to carry out the energy transition relying on China. As it stands, the energy transition could mean swapping a dependence on Middle Eastern and Russian hydrocarbons for a dependence on China for clean energy technology. Given the rising political tensions between China and the West, this may impact energy and climate policy. The EU and the US may need to secure the entire energy value chain and investigate domestic production. This could help guarantee the security of energy supplies in a decarbonized world. Okay, I think this is a great opinion piece in The Hill focusing in on the geopolitics surrounding the hydrogen value chain. Specifically, how the US and the EU can combat China, not just in the development of hydrogen, but also in the development of the critical components that the hydrogen industry needs to manufacture hydrogen, specifically electrolyzers and fuel cells. And as this article has already pointed out, China has already taken a commanding lead in the manufacturing solar panels and wind turbines for the renewable industry, and is aimed to take over in the exact same way for hydrogen equipment. And so the way it looks to me now is that the US and the EU are going to have to increase their economies of scale enough to not necessarily compete with China on economics, because that's most likely not going to happen, but to be able to produce a higher quality piece of equipment so that they can charge a premium price on it. Next, in a press release from April 3rd, Dominion Energy Utah starts hydrogen blending. Dominion Energy Utah launched hydrogen blending in Delta, Utah as part of an ongoing project to explore the opportunities this zero-carbon emissions fuel has to offer. Hydrogen is a clean, emerging energy source that holds enormous potential. It can be used to heat homes and buildings, power manufacturing, and fuel transportation, all with few or zero emissions. When combined with natural gas, hydrogen can be transported through existing infrastructure and used in appliances and equipment that are already utilizing natural gas. Dominion Energy is investing in hydrogen early, exploring how it can help achieve net zero emissions by 2050, while simultaneously helping decarbonize other industries like transportation, manufacturing, and power generation. The blending in Delta's pipelines is the next step of the Therm H2 project piloted by Dominion Energy Utah. The first phase was focused on blending hydrogen in the Utilities Training Academy to confirm hydrogen research that is currently available. A 5% hydrogen blend was tested for almost a year, finding that hydrogen was safe, compatible with current residential appliances, and helpful in reducing emissions from appliances using already clean-burning natural gas. In a quote from Judd Cook, Vice President and General Manager of the Western Gas Distribution System, the commencement of this project is very exciting for Dominion Energy Utah. He says, "We are always looking for ways to reduce emissions while still providing the reliable, affordable, and safe service that our customers expect from us. This project," he says, "provides an opportunity to do just that." Blending in Delta will occur over a multi-year period to reinforce the findings from the Training Academy and will help DEU, or Dominion Energy Utah, achieve its goals of preparing its entire distribution system to be ready to blend by 2030. An up to 5% blend will be introduced into the city as well as to the surrounding towns of Oasis, Hinckley, and Deseret, serving about 1,800 customers. The project will begin with gray hydrogen but will upgrade to green later this year. During the course of the project, the majority of hydrogen blending will be green hydrogen made from renewable energy. This project is one of the many ways that the company is focused on reaching sustainability goals and reducing emissions for the benefits of their customers, air quality, and the environment. Dominion Energy is committed to achieving net zero emissions by 2050 and has reduced methane emissions from its gas operations by 38% since 2010. Okay, so this is an interesting press release, and some of it is actually kind of surprising to me. What's not surprising is that they're using a 5% blend of hydrogen. That's a pretty conservative number, but definitely a standard that they can keep up with, and is in line with a lot of the other numbers that we've seen so far with hydrogen blending for residential services. I'm also wondering why they're using gray hydrogen for the first part of this project and then switching to green. Now, I understand why they're switching to green, but why not use something with carbon capture for the first part of this project? It's easy to come by, especially in this area. And they'll have a much better public buy-in if they can promote that the carbon produced with the hydrogen gets captured and or sequestered. And really, when it comes to residential utilization of hydrogen, I think back to the talks that I've had with natural gas operators and their concerns about hydrogen blending in existing pipelines, and that's just how much turbulence is in these lines. Now, with a 5% blend, it may not be that much of an issue if the gas sits stagnant within the line. But if they begin to increase that percentage, just how much could that stagnant hydrogen that rises to the top in that natural gas line corrode the existing infrastructure? All right. That's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is, that would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. And as always, take care, stay safe, I'll talk to you later. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.